Lesson 8 continued. So in the previous video, I showed you or reviewed with you how to add two fractions, rational expressions, by finding a common denominator and combining like terms. But the process of partial fraction decomposition actually works backwards. So how do you, if you start with this rational expression, how do you know what two fractions were added together to get this? So that's what this lesson is really all about. So we will learn the technique of partial fraction decomposition to write a rational expression as the sum of simpler fractions. In other words, we will determine two fractions that when added together will result in the given expression. In this case, we're going to start with this rational expression 19x plus 29 over x plus 6 times 3x plus 1. And we're going to decompose it into two simpler fractions. So since it's the example from above, we should wind up with this as our answer. So let's look and see how we do that. So we're going to use this process or this property if the denominator is a product of distinct linear factors, which this is because those x's are both to the first power, which makes them linear, and they are different. Then for each factor of the form ax plus b, so for each one of these factors of that form ax plus b, the partial fraction decomposition will contain a term of the form a over ax plus b, where a is some constant. So we're going to use this property to first write this fraction as the sum of two fractions with x plus 6 as one of those denominators and 3x plus 1 as the other denominator. Now we don't really know the numerators yet, so we're just going to label them a and b. Now I want to make a note here, because you might get frustrated in ALEX if you go farther than that in the first two problems. So the first two questions in ALEX want you to stop right here. So they do not want you to continue on and figure out what A and B are. They just want you to stop right here. But the questions after the first two questions will want you to continue to find A and B. So let's look at that now. How do you find A and B? So what we're going to do is we have an equation that we have set up now, this equation here. And there's a technique that you can use in algebra to simplify fractions, and that is multiplying by the denominator. And since this is an equation, as long as we multiply both sides by the same thing, they should still be equal. So I'm going to multiply both sides by x plus 6 times 3x plus 1. So when you do that, think of this as that over 1. And I think we've done this already in class. When you're multiplying and you have common factors in the top and the bottom, they cancel. So the x plus 6 cancels on the left-hand side, and the 3x plus 1 cancel on the left-hand side, and we're left with 19x plus 29 for the left-hand side. And that's equal to, well, if we look at this first fraction, the x plus 6 will cancel, so we'll have a times 3x plus 1. And then for this fraction, the 3x plus 1's will cancel, so we'll have plus b times x plus 6. So now you see we have this equation where we have no more fractions. Yay! All right, so now what we want to do is we want to go ahead and work on this equation a little bit. So I'm going to distribute a to the first set of parentheses, and I'm going to distribute b to the second set of parentheses. So I'm going to leave this alone, 19x plus 29, and that's equal to 3a times x plus a. So that's a times 3x is 3ax, and a times 1 is a, plus b times x would be bx, and then b times 6 is plus 6b. Now I'm going to rearrange this a little bit, and I'm going to get the terms that have x in them side by side. So I'm going to just move these terms around a little bit so that these terms are side by side. And the terms that do not have x in them will be side by side. And you'll see why I'm going to do that in just a second. So I have 19, whoops, sorry, let me change to a pen. So I have 19x plus 29 is equal to 3ax plus bx. So I just move this in between those terms, plus a plus 6b. And now we're going to use what we used at the beginning of this lesson. We're going to factor out x of these two terms. So that's going to give me 19x plus 29 is equal to, so I'm going to factor out x. Now in the beginning problem, I put x here, but you can also put it at the end. So I'm going to have two terms inside these parentheses because I have two terms here. They'll be separated by a plus. And what goes here is what you need to multiply x by to get 3ax. So that would be 3a. And what do you need to multiply x by to get bx? And that would be b. Then I'm just going to rewrite my last two terms. All right, so the next step is a little bit tricky, but the note I have over here to the left says two polynomials are equal if and only if the coefficients on like terms are equal. What that means is this. I have these two polynomials, one on the left and one on the right, that are equal. And they're only equal if the coefficient of x is equal and the constant term is equal. So that's going to allow me to pull these out of this polynomial and set them equal to each other. So I'm going to get 3a plus b, and that's got to equal 19, because on the left, that was the coefficient of x, and on the right, that was the coefficient of x. So if these expressions are really equal, then the coefficients of x have to be equal. Same thing with a constant term. So I have a plus 6b, and that has to equal 29. So if these two expressions are equal, then the number without the x has to equal the expression without the x on the right-hand side. Now you may notice what we have here is a system of equations. I have two equations that contain two variables, a and b, and we learned methods back in lesson 7 how to solve this system. So I can either solve it by elimination or substitution. I'm going to solve this one by elimination. So what I notice is that I have 3a here, and a here. So if I multiply this equation by -3 and add it to the first equation, the a's are going to cancel. So watch. -3 times a gives me -3a. -3 times 6b gives me -18b. And then -3 times 29 gives me -87. Now I'm going to add these two together. So 3a minus 3a, well, those cancel out. b minus 18b is -17b. And 19 plus -87 is -78. Now I can solve for b by dividing both sides by -17. So b is equal to 4. But I also need to find a. So to find a, remember you plug b into one of the given equations. It doesn't matter which one. I'm going to plug it in the first one. So I have 3a plus b equals 19. And then I'm going to plug 4 in for b. And that's going to give me 3a plus 4 equals 19. So now I can subtract 4 from both sides, and that gives me 3a equals 15. Dividing both sides by 3 gives me a equals 5. So I'm almost done. So now that I've found a and b, I can now write my fraction into two separate fractions. So 19x plus 29 over x plus 6 times 3x plus 1 is equal to a, which is 5, over x plus 6 plus b, which is 4, over 3x plus 1. So be careful about that. Remember, you need to put the 5 and the 4 over the right denominator. And if you remember, we let a be the numerator over x plus 6 and b be the number over 3x plus 1. And that's your final answer. Now let's see if it actually equals what we had started with in the first example. So if we look back up here, lo and behold, a was 5 and b is 4. And that's how you decompose a fraction.